Hi, in this video, I will show you how to reduce or convert the system of ODE to be input in Bvp4c solver in Matlab. So right here we have this system of ODE, which is equation 6 and 7 for the momentum and energy equation subject to this boundary condition. Okay, so first of all, what we need to do is, okay, I have copy paste the equation here. So this is equation 6 for the momentum. So as we can see here, the highest order for the f function is in triple prime, which is the highest order is 3. So for f prime, and f double prime, we need to assume it to be in terms of y. So here we assume f to be y1, and then f prime equals to y2, f double prime equals to y3, and then f3 per prime is come from these equations. So we need to rearrange these equations. Okay, so this one should be transferred to the other side. So we have that one to be minus and plus, and this one transferred to the other side. So we have 1 over this. So f3 per prime is equals to this one. So in this f3 per prime, we still have the f function. So we need to substitute according to the assumption we have made. So f here should be replaced with y1. F double prime we replace with y3. And f prime we replace with y2. So it is squared. So we have y2 multiplied by y2. Okay, the same goes for the another equation 7 for the energy equation. So the highest order is 2, which is theta double prime. So for theta and theta prime, we should assume it to be y4 for theta, because we just continue from the previous y, which is here. This is y3. So for theta, it should be y4, and then theta prime, it should be y prime. Okay, and then theta double prime is come from this equation. So we need to rearrange these equations. So this one should be minus, this also minus, and sorry, we transfer this one to the other side. So we have 1 over this one. Okay, so the same thing, there is still a functions of f and theta in this theta prime, theta double prime, so we need to substitute. F is y1, theta prime is y5, f prime equals to f prime is y2, theta is y4, and this one should be y4. Okay, so that's all for the ODE, and then for the boundary conditions, we need to convert it to be in terms of y. So here we have 2 types of boundary condition, which is firstly is when eta equals to 0, and second is when eta goes to infinity. So for eta equals to 0, we need to assume same as the previous assumption. So we have f here, f is y1. So for eta equals to 0, we assume it to be ya1, okay, equals to s. But in the code, we cannot put the equal sign, so we need to transfer s to the other side. So it should be minus s. Okay, and then we have f prime equals to lambda plus a, f double prime is 0. So f prime is y2. So it should be ye2 because eta equals to 0. And then here it is equal sign. So in this code, we shouldn't put the equal sign. So it should be minus lambda. And then minus E F double prime is Y3. So it should be YE3. Okay, that's all. Then for theta, the same. Theta is Y4. So YE4 equals to 1 plus B theta prime. So it should be minus 1 minus B theta prime is Y5. So YE5. Okay, and then for the eta goes to infinity, we let it be YB instead of YA because YA is for eta equals to 0. So F prime is Y2, so it should be YB2. It goes to 0, so we shouldn't put the equal sign to 0. So just YB2, and for theta is Y4, so YB4. Okay. So this is for the boundary conditions. And in this code, here I just show you how it is written in this code. So in this case, actually, we just skip for the function without the differentiation. For example, here we skip F and theta. So here we start with Y2 and then Y3. Okay, and then this one is ODE. And then Y4 we skip, and then we go for Y5, and last one is this. Okay, same goes for the boundary conditions. We just put all of these conditions, okay, here. So as we can see here, there are 5 items for each of these. So we have 1, 2, 3, 4, 5, and the same goes for the boundary condition. It is there are 5 items, meaning that the system is right. Okay, so that's all for this video. See you on the next one.